Hello friends, today we shall begin a new chapter in second year organic chemistry, and that is aldehydes, ketones and carboxylic acids. All the three compounds, aldehydes, ketones and carboxylic acids, they are commonly referred to as carbonyl compounds. They are called as carbonyl compounds. What are carbonyl compounds? These are the compounds which contain a carbonyl group. What is a carbonyl group? A carbonyl group is C double bonded O. Carbon oxygen double bonded group is called carbonyl group. Aldehydes, ketones as well as carboxylic acids, all the three contain carbonyl group, hence they are called carbonyl compounds. In aldehydes, the carbonyl group is attached on one side by alkyl or aryl group and the other side by hydrogen. A ketone has carbonyl group attached on either sides with alkyl or aryl groups, whereas carboxylic acids has a carbonyl group attached on one side with alkyl or aryl group and the other side with hydroxyl group. So sometimes carboxylic acids are technically not exact carbonyl compounds. They are not exact carbonyl compounds because in addition to carbonyl group they also contain hydroxyl group. So carboxylic acids are a class of organic compounds which we refer to as they are bifunctional group containing compounds, that is they contain two functional groups. So exactly telling, the two compounds which are carbonyl compounds are aldehydes and ketones. Carboxylic acids also contain carbonyl group. In addition to it, it also contains hydroxyl group. Therefore, the properties of aldehydes and ketones are almost similar but strikingly different from carboxylic acids. So in the coming classes, when we study aldehydes, ketones and carboxylic acids, most of the time we take aldehydes and ketones along and we separate carboxylic acids. The only reason is that their methods of preparation, their nomenclature, their properties are entirely different from aldehydes and ketones. So now we shall begin aldehydes and ketones and not carboxylic acids. So I did tell you that aldehydes and ketones are carbonyl compounds. Carbonyl compounds are those which contain carbonyl group in them, C double bond O group in them. In aldehydes, the carbonyl group is attached on one side with alkyl or aryl group, the other side with hydrogen. With only one exception, for formaldehyde, this R can also be hydrogen. Therefore, this R could be an alkyl group, it could be an aryl group, or it could be hydrogen also. This is only for aldehydes. Whereas in ketones, this R and R dash, they are alkyl or aryl groups. Both can be same or different. Now based on the nature of this R, aldehydes as well as ketones, they are classified into two types. One is aliphatic and the other is aromatic. If the R group attached is an alkyl group, if it is an alkyl group, then such aldehydes or ketones are referred to as aliphatic aldehydes or ketones. If it contains benzene ring, if the R is benzene ring, then we say they are aromatic. Aldehydes and ketones are classified as aliphatic and aromatic based on the nature of R group attached to the carbonyl group. If R is an alkyl group or hydrogen, then it is aliphatic aldehyde or ketone. If R group is benzene ring, phenyl group, then we say such compounds are aromatic aldehydes or ketones. Having said that, now let us begin with their nomenclature. The nomenclature of aldehydes and ketones are different. So we shall study first about aldehydes followed by ketones. To understand, let us see some examples how they are named along with their common names and IUPAC names. In common naming system, as we all aware that there are two systems, one is common naming system and the other is IUPAC system. In common naming system, the names of aldehydes are derived from common names of carboxylic acid. You may ask how. You might be knowing what formic acid is. Formic acid is this compound. This is formic acid. Formic acid is called formic acid because it is obtained from red ants. Red ants are otherwise called formicus in Greek and Latin names. So, from formic acid, the name of corresponding aldehyde is derived. All aldehydes contain this group as common, that is aldehyde group as common. If this is R, it is an aldehyde. Now each time I will replace this group by either alkyl group or aryl group or by hydrogen. So corresponding names are obtained. Now the common names of aldehydes, not all common names, the common names of some aldehydes are derived from the common names of carboxylic acids. For example, see, in this compound there is only one carbon. It is called formic acid. Commonly it is called formic acid. The same corresponding aldehyde is this compound. So how are they named? I did say the common name of aldehyde is derived from the common name of carboxylic acid by replacing the last ic acid with the word aldehyde. Since both of them contain one carbon, therefore its common name will be formaldehyde. Understood? In common naming system, the common names of aldehydes are derived from the common names of carboxylic acids by replacing ic acid of corresponding carboxylic acid with the word aldehyde. That's all. If the chain is long, if in aliphatic aldehydes, if the chain is long, for example, see this example wherein the chain is made up of 5 carbon atoms. If the chain is made up of 5 carbon atoms, then how do you name this compound? Excluding the aldehyde group, the next carbon atom is labeled as alpha. The next carbon atom is named as alpha, followed by next carbon beta, gamma, delta, etc. So in common naming system, since we do not use numbers 1, 2, 3, etc. as they are used in IUPAC system, here in common naming system, excluding the aldehyde group, the first carbon to which aldehyde group is attached, it is labeled as alpha, the adjacent carbon beta, gamma, delta, and so on. Now, how do you name an aldehyde in IUPAC system? In IUPAC system, aldehydes are considered as derivatives of alkanes. They are considered as derivatives of alkanes. While writing their names, the last letter of alkane, E, is replaced. If you say this is an alkane, then the last letter E is removed by the first 2 letters of the word aldehyde. The first 2 letters of the word aldehyde is Al. So Al is attached. Therefore, the IUPAC name of aldehydes is alkanal. The IUPAC name of aldehydes is alkanal. Now, how do you name? Based on the root word, you name an aldehyde according to the number of carbon atoms present in it. If it contains only 1 carbon, meth, 2 carbon, eth, 3 carbon, prop, and so on, followed by their primary suffix, that is either single bond or double bond, and lastly by secondary suffix, it should be Al. The IUPAC name of aldehydes should end with Al always. So Now this formaldehyde can be called in IUPAC system as, since there is only one carbon, root word for one carbon is meth. Since it is single bond, ane. Most of the students confuse while writing ane, they continue this E. There is a rule that while you are naming aldehydes, the last letter E should be removed. It should be removed. And what should be attached? The first two letters of the word aldehyde should be attached. Therefore, it becomes methanol. While writing, some students can write this as Al. They say it is Al only. It is wrong. Write Al in this form. Otherwise, split them. So, methanol is the correct IUPAC name of this compound. Now, you understood how to name an organic compound, an aldehyde in IUPAC system. In IUPAC system, the names of aldehydes are considered as derivatives of alkanes. While writing the IUPAC name of aldehyde, the last letter of alkane E is replaced by the first two letters of the word aldehyde. Hence, the name becomes alkanol. Now, let us see a few more examples. If it is 2 carbon chain, this part remains same. Now, since there are 2 carbons, how do you name this compound? This is considered as a derivative of which carboxylic acid? This carboxylic acid. And how do you name this carboxylic acid? You called it as acetic acid. So, acetic acid was its common name. Now, its a derivative is this aldehyde. So, how do you name? Ic acid is removed and what is attached? Aldehyde. Therefore, the name will become acetaldehyde. Acetaldehyde. In IUPAC system, since there are only 2 carbons, therefore eth, single bond ane. Since it is an aldehyde, Al, ethanol is the IUPAC name. Next, for 3 carbons. For 3 carbons, how do you name? Its common name is propion aldehyde, because its name is derived from propionic acid. Propion aldehyde. IUPAC name 3 carbons, prop, ane, al, propanol. Then 4 carbons. 4 carbon carboxylic acid is called butyric acid because it is obtained from butter. So, its corresponding aldehyde is butyr aldehyde. Butyr aldehyde. IUPAC name 4 carbons, therefore butane butanol or butanol. The same 4 carbon with slight rearrangement. Now, this is called isobutyr aldehyde. It is called isobutyr aldehyde. Now comes a new part. How do you name this compound in IUPAC system? Compulsorily follow numbering. How do you number? Always remember, if the organic compound is containing a functional group in it, the functional group should get the least number. It should be given highest priority. So, whichever functional group is being given highest priority, it should be given the least number possible. This is first rule. Second, if the functional group contains carbon in it, like aldehyde, ketone, carboxylic acid, all of these begin with carbon. So, if they contain carbon in it, then that carbon should be labeled as 1. I mean to say, if the functional group has carbon in it, you consider that as first carbon. If the functional group does not contain carbon, then to whichever carbon the functional group is attached, that should be considered 1. Like in alcohols, the functional group is OH. Since OH does not contain carbon, therefore to whichever carbon OH is attached, that carbon is labeled as 1. Here, aldehydic functional group contains carbon in it, therefore it should be labeled 1, the next carbon 2, the next carbon 3. So this time you have a substituent at second carbon. Which substituent? Methyl group. So 2 methyl, longest chain is of 3 carbons, therefore propanal, 2 methyl propanal. Some more examples. The next compound should be now of 5 carbon chain. CH3, CH2, 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 CHO. Its name is derived from its corresponding carboxylic acid, that is valeric acid, therefore valeraldehyde. Valeraldehyde. Now what should be its IUPAC name? There are 5 carbons, therefore pentanal. Pentanal. Its common IUPAC name is pentanal. Now some other different examples. You need not remember the common names of all organic compounds in the exams. If your point of view is with respect to exams, then writing the common names is not required. Sometimes they may ask you to write IUPAC names only, but not common names. Therefore, even if you do not remember their common names, it is fine. Like for this example, I said it is valeraldehyde. You might say, sir, for this compound I can remember, I can recall its IUPAC name looking at its root word and all of that. That is easier in IUPAC system. But in common naming system, names are given based on their scientists who have discovered, based on the source from where it is obtained, etc. So even if you do not remember its common name, it is fine, because in the following examples here and there you may not find common name. I'll put simply a dash. This indicates that it does not have a common name, or even if there is a common name, it's not more relevant. Therefore, for this reason, even if you do not remember the common names of some organic compounds, it is fine. For this compound, at least guess its IUPAC name. There are 3 carbons, so the root word should be prop. Then, so okay, I'll write IUPAC name prop. Now, begin numbering. Some of you will get confused. Sir, there is double bond as well as aldehyde. Who should be given preference? Always remember, functional groups comes first in priority, followed by multiple bonds, then comes substituents like alkyl groups and others. So begin numbering from here. So how do you name? Prop. The double bond begins at second carbon, therefore prop 2 ene dash 1 dash al. Even if you are not able to write this entire name, you can write prop 2 enal. It is also correct. Some books give the name as 2 propanal. This method is wrong. Do not follow this method, because it confuses us whether the double bond is at second carbon or aldehyde is at second carbon. So technically writing a name in this method is not correct. Follow this method or the first method. This would be more accurate. Now let us see some aromatic compounds. All aromatic compounds, all aromatic aldehydes are considered as derivatives of benzaldehyde. Its common name is benzaldehyde. And benzaldehyde also becomes the IUPAC accepted name. It is now an accepted IUPAC name. Even though it is common name, it is now an accepted IUPAC name. I forgot to write its name. Common name, it is acrolein. You may say, sir, why there is no aldehyde in it? We have no idea. It is simply called acrolein. Now this compound is benzaldehyde. Let us see some more examples. What if benzaldehyde is substituted? What if benzaldehyde is substituted? Like this compound. How do you name this compound? In common naming system, when there are 2 substituents, that too in aromatic compounds, we use what prefixes? Ortho, meta and para. When is ortho used? When it is 1 2, if it is 1 3, if it is 1 4. Now see, the carbon which is attached to aldehyde group in aromatic compounds, it is labeled 1 2 3. You may ask, sir, you said this should be counted while writing, this should be counted as 1. Why aren't you counting this? In aromatic aldehydes, the aldehyde group is not a part of that chain. So the benzene carbons are considered as part of chain. Therefore, to whichever carbon aldehyde group is attached, that is labeled 1 2 3. Therefore, the correct IUPAC name will be 3-bromo-benz aldehyde. 3-bromo-benz aldehyde. Whereas IUPAC name 1 and 3 are called meta. So meta-bromo-benz aldehyde. Meta-bromo-benzaldehyde. Other examples, not many more, only 2 or 3 are enough now. You can follow for more examples NCERT textbook. What do we call this compound? Whether it is here or here, it is simply a benzaldehyde. Now, how do you name this compound? Its corresponding carboxylic acid is phthalic acid. Therefore, it is called phthaldehyde. It is called phthaldehyde. Its IUPAC name is benzene 1,2 diol. Is this correct? Benzene 1,2 diol, or else benzene 1,2 dicarbaldehyde. This is more accurate name than benzene 1,2 diol. What if you have cyclic aldehydes, like in this case? In such cases, where there is no aromatic chain, it is simply cyclic aldehyde. Then in IUPAC system, you are supposed to attach a word carbaldehyde before the name of, after the name of the cyclic chain. That is a 6 compound chain. Therefore, it is cyclohexane. It is cyclohexane carbaldehyde. There is no common name. The last example, okay, not this one. How do you name this compound? There is no common name for this compound also. How do you name this compound? Now, you begin numbering from aldehyde group 2, 3, 4, 5. Most of the students do this mistake. If you count in this way, you did not consider this as part of chain. So, in order to give equal preference to all the aldehyde groups, this chain is numbered as 1, 2, 3. So, the 3 carbon chain is called propane dash 1, 2, 3. 3 times aldehyde has appeared. So, tricarbaldehyde. Propane 1, 2, 3. Tricarbaldehyde is the IUPAC name. If this is done, now we shall study the nomenclature of ketones. Nomenclature of ketones. Ketones are named again according to 2 systems, common naming system and IUPAC system. For example, if this is one ketone, this is carbonyl group. On either sides there are alkyl or aryl groups which are same or different. If they are same, we call them as simple ketones. If they are different, then we call them as mixed ketones. Now, based on the nature of alkyl or aryl groups, they are named. The simplest ketone is this one. How do you name this compound in common naming system? In common naming system, the names of ketones are derived from the names of alkyl groups. This alkyl group is called methyl, the other alkyl group is called methyl. If it has appeared twice, then you write dimethyl. The name should end with ketone, that's all. Dimethyl ketone. It is simply known as acetone. In common naming system, not all ketones have common names like acetone. They are named by considering the names of alkyl or aryl groups attached on either sides of the ketonic group, and the name should end with this group as ketone only. Whereas in IUPAC system, ketones are named according to the same rules. Based on the chain length, we have 3 carbons, therefore prop. All of them are single bond ane. You may say, sir, there is one double bond between carbon and oxygen. This is not counted. Only the bonds between carbon and carbon, they are seen. If they are single, therefore ane. E should be written. If it is a ketone, then the last letter E should be removed with the last 3 letters of the word ketone. See, the last 3 letters are one. If the same is to be attached to alkane, then the last letter E is removed and ONE is attached. Then alkanone becomes the IUPAC name of ketone. Then this name propanone. It is propanone. Which propanone? See that the double bonded carbonyl group is present at second carbon, therefore propane 2-one is the correct IUPAC name of this compound. Now, if there are cyclic ketones, then the numbering should begin from ketone group only. Always ketone group is not numbered 1. The chain is numbered in such a way that ketone group gets the least number. See, ketone is not terminal functional group. It appears in the middle of the chain. Therefore, if the chain is longer and ketone is somewhere, then you have to number the chain in such a way that ketone group gets the least number. That does not mean you should begin numbering from ketone. From the end nearing to ketone group, that should be considered. If it is a cyclic ketone, in such cases ketone group should be numbered 1. Now let us see that also in the coming examples. If this is the case, for this case, see the nature of alkyl groups. One side you have methyl, the other side you have ethyl. So how do you write name? Methyl, ethyl. The name should end as ketone. Now tell whether this name is correct or wrong. I said you have to name a compound based on the alkyl groups present on either sides of the ketonic group. If that is said, it is true. But yet this name is wrong, because while writing the name of alkyl groups, you have to follow alphabetical order. Therefore, this comes first, ethyl, then comes methyl, followed by the last name ketone. Ethyl, methyl, ketone. IUPAC name, I did say you have to number the chain in such a way that ketone group gets the least possible number. You cannot count from here. Count from this side, 1, 2, 3 and 4. Therefore, 4 carbon chain is but, all are single bond ane. Double bonded ketone group is at second, therefore butane 2-one is the correct name. Then let us see how do you name this compound. This time it is 5 carbons, one side ethyl group, the other side ethyl group, therefore the common name is diethyl ketone. How do you name in IUPAC system? 1, 2, 3, 4, 5. Pentane. Pentane, which one? 3-one. Pentane, 3-one. If it is this compound, again 5 carbon chain, but the position of ketone group is different, then 1, 2, 3, 4, 5. Pentane 2-one. It is pentane 2-one. What about common name? In common naming system, one side you have methyl, the other side you have propyl. Therefore, it is methyl N-propyl ketone. It is methyl N-propyl ketone. Let us see one more example. This time again you have 5 carbon atoms, 1, 2, 3, 4, 5. How do you name this compound? Now you may say, let us see in common naming system there is methyl group. This group is not propyl group. Now it is isopropyl group because ketone is attached to the second carbon. Therefore, methyl isopropyl ketone. Some students will have doubt. Sir, you said we have to follow alphabetical order. Why aren't you following alphabetical order in this example? Because I should come first, then comes methyl. If I am not wrong, I have told you this in the last classification of ethers also, that iso, neo, etc. they are not to be considered while numbering, while naming. So M and P are considered. Understood? So this name is correct name. Now in IUPAC system, you are supposed to number. How do you number? If I count from this side 1, 2, 3, 4, ketone group will get second number and methyl group will get third number. Some of the students will count from this side 1, 2, 3, 4. So ketone group will get third number. Which one is correct? Functional group should be given least number as it is getting higher priority. So this numbering is correct. 3 methyl butane, which one? 2-one. 3 methyl butane 2-one is the correct name. Then let us see some aromatic compound examples. Only some 2 and 3. One side you will have benzene ring this time. Ketone group remains same, followed by an alkyl group. So this is an example of mixed ketone. How do you name this compound? One side you have methyl group, but this much part in aromatic ketones it is called phenone. If ketone is attached to benzene ring, then it is called phenone. This group is called acetyl group, therefore it is acetophenone. Acetophenone is the common name for this compound. Technically not true. The correct common name should be methyl phenyl ketone. If methane becomes methyl, then benzene becomes not benzyl. Benzene becomes phenyl. So methyl phenyl ketone. IUPAC name is also acetophenone, which is now accepted IUPAC name. Even though it is common name, it is now accepted IUPAC name. Then what if we have 2 benzene rings attached to the ketone group? How do you name this compound? One part is phenone, the other is again benzene, therefore its common name is benzophenone. Benzophenone. The same name continues, benzophenone. Then how do you name this compound? It is a cyclic ketone. I did not tell you about cyclic ketones. So in cyclic ketones, first you write the name of the cyclic structure. It is cyclopentane. Okay, cyclopentane. Now while writing the name, the last letter E should be removed. I will remove. Attached by one. So it is cyclopentanone. The same name can be written for common name also. What if it has got substituents, like in this case? How do you name this compound? How do you name this compound? Now, I will not write common name, though it has a common name, I will not write. First I will write IUPAC name. If CH3 was not present, you would have written its name as cyclopentanone. You would have written it as cyclopentanone. But what kind of cyclopentanone? Now see. This is labeled as 1. In cyclic ketones, ketone group is numbered as 1, 2, 3. Therefore, it is 3-methyl cyclopentanone. In common naming system, if it is cyclic ketone, then the ketonic carbon is labeled alpha, followed by beta, then gamma. Then it is gamma methyl cyclopentanone. It is gamma methyl cyclopentanone. If you have understood the 9th example, try on your own about this example. How do you name this compound? How do you name this compound? Okay. This is first carbon, this is second carbon. Therefore, 2-bromo cyclohexanone. 2-bromo cyclohexanone is IUPAC name. Common name, this is alpha and this is beta. Therefore, beta bromo cyclohexanone. Beta bromo cyclohexanone. The last example. Now tell, how do you name this? How do you name this compound? It is called, this should be given 1, 2, 3. So 1-phenyl propanone. I told you, because if there are cyclic ketones or aromatic ketones, then ketone group is numbered as 1. 1-phenyl propanone. You need not worry about common name. There is one thing you have to remember when it comes to the nomenclature of aldehydes and ketones. Till now you have studied only aldehydic nomenclature and only ketonic nomenclature. What if both the functional groups are present in the same compound? What if both the compounds are present in the same compound? For example, see. If this is one example given, then if both aldehydes and ketones are present, how do you have to give preference? Then always remember, aldehyde gets preference over ketone. Aldehyde is the superior functional group when compared to ketone. So who should be given least number? Aldehyde should be given least number. Then comes ketone. Therefore, its IUPAC name will be 3. Now, till now you know only that whenever it is a ketone functional group, the name should end as -one. What if it is not the main functional group? In this case, C aldehyde has become the main functional group, so the name should end as Al, al. Name should end as aldehyde. Now, when ketone is not the main functional group, it is to be called as what? It is to be called as oc. Some books give it as keto. 3-keto pentanal. 3-keto pentanal. 3-keto pentanal. But most of the authors say writing keto is not exact or more precise. To be more precise, the name is 3-oxopentanal. This becomes the correct name. Oxo is the correct word for ketone whenever it is not the main functional group. Whenever it is treated as the second functional group, it is to be prefixed as oxo. If they have given keto, you understand it is ketone functional group, but you do not go and write keto. Keto is not the correct word for ketone to be written as a secondary functional group. When there is main functional group aldehyde, then ketone is to be written as oxo only. Understood? Fine. So today we studied about the introductory part of aldehydes and ketones, the nomenclature of aldehydes and ketones. In the coming classes, we shall study about their methods of preparation. Thank you.